Hello, welcome back to the Oracle SQL tutorial. In this tutorial we are going to discuss about database subjects. So Oracle database contains multiple data structure, like for example, one of your data structure you already know is called table. Okay, so like table there are many different types of data structure, and in this tutorial we are going to discuss about all those very popular data structure, and we will dig deep why we need those things, and then what is the how to use them. Okay, so let's make a table where we say what are different types of data structure. So I'm going to do the type of object, and this is some description about them. The first one we have already discussed is table. So table stores, this is the simplest unit of storage where we store data in a row and column. And next one is view. Let's see why we want to use a view. So here is a table emp, and then if I do a query from this emp table, I'm getting all this data. Okay, so let's say this table emp exists in a so this is one schema where my emp table exists, and let's say this schema is user A. Okay, so user A has an access to this employee table, and then he has stored all the information about employee in the employee table. And if we query the employee table, it would look like the data is going to look like this. So we have in this same database we have another user, and let's say this is called user B. Okay, so user B wants to access this table emp. Okay, so in that case what user A is going to do, user A is going to give user B a select privilege so that he can query this table. So when user B logs in, and then if he does select star from user underscore a dot emp, so this is how we're going to write, because the table is existing in this schema of user A. Okay, so therefore you give the username dot table name. Okay, so this is how we'll determine. So user B gives a select star from user A dot emp, then it if right kind of privileges are given by user A, then user B can access all this data. So here a couple of questions are there. Should user A make sure that user B can access the sensitive data called salary? Okay, so is it necessary for user B to see this sensitive data? If the answer is no, then how to solve this thing? You have two options. Say option 1 is you are going to user A is going to create another table called, let's say, employee underscore A. In employee underscore A, he will not have this column called sal. That means he will create a table exactly replicating the emp table, but salary column will be missing there. So in that case what happens is, and then employee user A remove the access of emp table, and then user A allows user B or any other users to access this emp A table. Okay, so that is one way. So in this way the disadvantage is that I'm going to replicate a complete table again. That means almost I'm storing the same table twice. And if tomorrow there's somebody do not want to see department number, right, then you have to do again another table called emp underscore A1, and which will not contain department number. So this is not a solution. Instead of that, what they do is that create a view. Okay, so instead of creating this emp A table, so what we do is we create a view. Okay, on this table. Okay, so when you create a view is basically simply a select statement. Okay, Okay, so what you do is you do something like create view, say X as select all the columns, employee number, e-name, jobs, manager, hire date, but not sal. Okay, if you ignore a column, you just ignore that, and then you select all other columns, and then let's say this view name is v1. Okay, so remember this view v1 is nothing but a select statement. Okay, so now you give the access of this v1 to other users, and that means if I do select star from user a dot v1, then it will contain everything but the salary column. Okay, so that is the advantage of view, that we make an window, right? And then say for example, another example of view, let's say I do not want to see any employee whose salary is more than 3000. So then what I do create a view on employee where I select star from emp where salary is less than 3000. So in that case the salary 3000 rows will not be there, and whoever is accessing that view, they can only access the data that is fetched by the select statement. Okay, so basically what we achieved here is that we do not have to store it again, and still whatever the problem that was given we could do. Okay, so that means the first important advantage of view is restrict data access. Number two is, let's say imagine that employee and deputy. Okay, the query that we wrote in the join video. Okay, so we have to write a complex query, right? What you can do is one time you write that complex query and make that as a view, so that remaining time we are just going to select from that view. Okay, so basically this makes complex query easier. Okay, so you abstract whatever the complexity to a view and then you select from that view. Okay, so this is why we create view. Remember, view never ever stores anything. View is just a select statement that we use when we need. Okay, so next so this is what the view. So view basically is a logically represents subset of data. Okay, and the next one is something called a sequence. Okay, so let's try to understand what is sequence. So let's say I have a employee table. In employee table I have employee number. Okay, so I describe that employee number is a primary key. Okay, and also what I want to do is that I want to employee number in a sequential order, like 1 2 3 4 5 6 7 8 9 10, like this. Okay, so that means if I have 10th employee, then the next thing that I want to get two things. One thing is that it should be a unique number and it should be a sequential way. So in that case what we use a database object called sequence. Okay, so that means we create a sequence and then we give what is the start with, like not which number is going to start. So if we start with 10, that means when you want to fetch the sequence, it's going to start with 10 11 12 13, like this. So it will increment by 1, and then you can also give at what point it want to recycle and all this thing. Okay, so we use sequence to populate a primary key, because sequence is a object that will always give you a unique key, a value that was never got before. And then how do you first create the sequence, and then you fetch the sequence by a statement called sequence.nextVal. So let's do a quick exercise here. Okay, so I do create sequence. Let's say sequence name is x1. That's it. Okay, so I have created a sequence, and now if I do select x1 dot next val from dual. So it will give me the value is 1. If the next time I hit the query, it will give me 2, like this. So let's say I want to create a table, say A1. I give a number like this. So what I can do is I can insert into this table A1 values. So whatever the sequence that I got, x1 dot next val. Okay. So what happens is that if I do select star from A1, I'm going to get 4, and next time if I do another insert, select into A1 values x1 dot next val. I think I made a mistake. Select into so oh sorry, I think I did make a mistake. It's not select, it's insert into. Okay, so if I do select star from A1, I'm going to get 4 and 5 and so on. Okay, so I'll make a so the goal here is that once you create a sequence, it is guaranteed that you are going to get a value that is not duplicate. Okay, so that is always a unique value that we are going to get out of a sequence. Okay, and then this is what we use a lot of time, sequence, to populate the primary key. Okay, and so let's go back to our slide, and then so this is what we define sequence. So this is generates primary key. The next one is index. Okay, so let's try to understand what can be an index. So let's say I have this table called EMP. So let's go back and then get my okay. So these are my data. I'll just clean it a little bit so that it will be easier to explain. Okay, so let's say this is my my data set from EMP. Okay, let's say in this simple example I have only, I think there are 14 rows here. Okay, but imagine if you have a 1 billion employees or 1 million rows of employee. Then when I do select star from EMP, where employee number is equal to say 7934. So how those things are going to happen is that the relational database is going to look in this way, that you're going to start from here. So 7839, right? So this is not, so then it will go like this, and again go like this, like this, like this, like this, and then it will find out 7934 in the very last row. Then that will fetch me, it will fetch me this row, and then again it will go traverse. So this is called full table scan. Okay, so if I want to query this table with for a particular employee number, then what is going to happen is that it's going to happen in this way. This is definitely time consuming. Okay, and then if I have a million row, by the time the query finishes, maybe too long. Okay, so how do I solve this problem? So let's do something. Let's basically go back to thing, and then so this was my original table, and then what I do is my query was the query that I wrote was select star from EMP, where EMP number is equal to 7934 or something like that, right? So why don't you store this data in another table? Okay, so I'll store this data 7839 7698 so on in another place, and then what is the address of this row. Okay, so this the address of this row, let's say it's called A1, this is A2, A3 and so on. Okay, so what I'm going to do is I'm going to store like this, whatever the where clause, that value and this address before I run this query. Okay, so if I do this thing, then what I'm going to do is when it comes to me that employee number 7934, first go on and scan this table. Okay, so scan this table where we have 7934. Let's say 7934 is last one and my address is A14. So now when I scan this thing again, I'm going to do this way. Okay, but the good thing about this thing is this is just only 2 columns instead of 8 to 9 columns. So therefore this scanning is going to be faster. Okay, so this scanning is going to be faster, and I know what is the column name, so what is the row address. Okay, so for 7934 the row address is A14. So I'll go after that, I'll go to this table and then look at the A14, okay, this row, and I'm going to fetch this row. Okay, so basically this is called index, and that is why we need an index. Okay, in index we are storing a, whatever the key that is being queried, the condition where we are putting an employee number. Therefore whatever the query that is going to be used in the where clause, we store it in separate table, that is called index table, and then whenever you run a query we use index. The reason behind doing index is going to make it faster. Just a complete analogy, look at your book. In your book, maybe that your main book consists of say 700 pages, and the very end you are going to see 10 pages of index. What you do if you want to learn about some concept, so you first go on and scan this 10 page and where this say where this thing is there, then you go back in that index, you find out on which page you have this concept, and then you go back to the main pages and to that page and then to. So instead of scanning the all 700 pages in the book, you first look at the index page and then go back. So the same concept that we are going to use in Oracle database, and index is with the object that does that. Okay, and then you do a the syntax for this thing is called create index on employee number. Okay, something like this. So again, like we create this index, so automatically this table is going to be created by you. Next time whenever you do a select, instead of doing a scanning full table scan, it will first do the index scan, and if the index scan, it will get the row ID or the address, and then from the row ID it's going to go to the main table and fetches. Okay, so the index is basically, it improves performance of query. Okay, this last one, there's a lot more objects, but the more important objects is called synonym. Synonym basically is another name. Okay, so synonym is basically nothing but another name for an object. Let's say I create a table EMP. Okay, let's say so this is, again, let's consider about something. This is called user underscore A. User underscore A has a table called EMP, and then here is another user called user underscore B. So user underscore B is accessing this table EMP. Okay, so let's say user B wrote a program where he wrote a lot of things about select star from user underscore A dot emp. Okay, and then he, there's another user somewhere else, his name is user underscore C. He also wrote his PL SQL program or some program where he referring to this table as user underscore A dot emp, and so on. Okay, so if all of these people are depending on this table EMP, okay, and then they have written there all their programs, sometimes thousands lines of code, 10,000 lines of code already written. Now let's say for whatever reason this user A rename this table to something called emp1. Okay, when the moment it renames this table to emp1, that means this table is no more there. So what we have is just only emp1. So if we have emp1 and then the next time the user B runs this query, select star from user A.emp, then this is going to give you an error saying that emp table is no more existing. Okay, so in that case, and then this program is going to fail, this program is going to fail, and so on. Okay, so therefore how to do it? So basically what you do is whenever you create this table emp, okay, you create a synonym for this table. Let's say synonym is XYZ. Okay, so the new name for this, the second name for this emp table is XYZ. Okay, then user A will tell other people that query from XYZ. Okay, so don't use emp table, just query user underscore A dot XYZ. Okay, then even if it's rename, like user A, if it's renamed to employee1, then what he can do it, after he renaming the table to emp1, he can recreate this synonym. But remember, the synonym name remains same. Okay, so what user A is going to do, he is going to delete emp. If delete emp means there is no more, this XYZ synonym is not referring to anything right now. Then user A is going to create this table employee1, and then is going to recreate this synonym so that XYZ is now pointing to emp1. So the moment these guys are going to query from XYZ, they are actually querying from employee1, emp1. Okay, so in that case what we have done is, whoever is using this employee1 or emp, they are not going to change, they are agnostic to this change, and by using synonym we are able to do that. Okay, and another, so this is the use of synonym, is that with the first use. Second use, that we can hide the table name. The real table name can be hidden from the other users. You just use a synonym. Okay, so that's a data, the security feature that synonym can give you. Alright, so this is the last one that we discussed about synonym. So it gives an alternative name to a object. Like basically we just give a table. Also you can create a synonym on view, you can create a synonym on sequence, and so on. Okay, so alternative name to objects. Okay, so these are the 5 very popular database subjects. But having said that, I don't say that there's not more database subjects. So you can go and then see yourself. Like say for example, this is our application, our SQL Express. And if you go to this called object browser, you click on that, then you'll see what are different types of objects like store procedure, functions, database links, materialized views, synonyms, and all these things are objects. Okay, and what you can do is you can select from a table called user underscore objects. And then you can basically see what kind of distinct object name is available on the database. Okay, so with this, this is the last video for this SQL tutorial, and in the next videos we are going to do more examples and more kind of more doubt clearing than the concept, and more exercises and all. Thank you so much.